So in the ALMA project, Scaleout has had the responsibility for target area autonomy. So the scenario is, multiple hostile assets have been known to be located somewhere within this sector. And our platform is ready for full autonomous recon and also full autonomous engagement. In this demo, we turn what is usually a pilot into a controller. And what I mean by this is that there is no other manual inputs than just the press of a button to start the system. On the screens, you will see the drone initiate the autonomous recon mission. The drone will detect, identify, and geolocate all spotted potential threats with the use of AI. All of the data is handled by the dedicated onboard computing, allowing the system to perform in real time without any external processing. But recon is only the first part. Using that onboard intelligence, the system will automatically execute prioritization logic and select the highest value target and initiate an engagement to deliver a fuse payload, still with zero manual input. When the highest prioritized target is within sight, the drone will correct its flight path to accurately drop the payload. Now the drone has fully initiated and the recon has started. In the live drone camera interface, you can see exactly what the drone is seeing. In the top left corner, you can see information about the system. Things like flight mode, we're automatic right now. State, we're in recon state. Payload status, we're armed and ready. If we have any prioritized target yet, which we don't. Detections, mission time, and frames per second of the system. In the recon state, the drone will search along a fixed flight pattern that later can be seen on the map that you have right there. So the red triangle or arrow is the drone's live location, and the red path is the path that it has taken. Let's see, now we're closing in on the command vehicle, and we see that the system is able to correctly detect and identify this vehicle. These detected targets will pass through the prioritization logic, and later the highest priority target will be chosen when the drone reaches the final search coordinate. Now closing in on the next target, which is an armored engineering vehicle. And the number you see there is the confidence level of the machine learning model that is on board on the drone. So let me remind you that all of this computing and autonomy is running on the onboard computer that is located on the drone. There is no manual inputs at all. Now we see a third target there, so we have 3 detections up in the left corner, which is the gravestone radar. What this also means is that if you see any disturbance in the video, that does not affect the system. The drone is fully independent and does not need a radio connection to function correctly. It will still carry out the mission as instructed, even with a complete loss of communication. So if you see any lag, that's only the radio signal between the controller and the drone, making the visuals a little bit glitchy. So now we're closing in on the 4th detection, which is the S400 system. Here you can see it from a third point of view. And now we see we are closing in on the final search coordinate, and it's only been about 200 seconds of this recon mission that's been fully autonomous. Now the drone has reached the final search coordinate and the transport state has been initiated. The drone will prioritize between the different detected targets according to the mission requirements. And in this demo, the requirement is to engage the armored engineering vehicle. The drone will use the approximated geolocation to calculate a vector from the drone through the target to be able to deliver the fuse payload. As the drone closes in on the prioritized target, it will initiate the approach state. When the target is in sight, the drone will fine-tune the final flight path according to the relocation of the target. And this is to compensate for any movement and to make the delivery as accurate as possible. So now we're closing in on it, and the approach state should be initiated any second. Now you can see that the drone is fixing its flight path, fine-tuning it, and we consider the mission a success if the AAV is in the center bottom of the screen when we fly over it. And then we can engage the target. Now the mission is complete, and in less than 320 seconds, the platform has carried out a fully autonomous recon and fully autonomous engagement mission. It has successfully targeted, identified, prioritized, and engaged the highest value target without a single pilot command. Let's see, looking at this replay, we can see that we are accurately able to deliver this fused payload over the highest prioritized target. So what you have witnessed is the move from a remote controlled system to an intelligent, autonomous, and independent system where pilots instead act as controllers. By removing the need for a constant connection, we've created a system that is resilient against electronic warfare and signal inference. So Scaleout is proud to show the future of defense isn't just about faster hardware, but about smarter, more reliable edge intelligence.